3 developer-focused AI updates landed this week. Sakana released Fugu Cyber, a security-specialized endpoint with published benchmarks. Reactor published OpenDreamer, a JAX Flax Dreamer 4 reproduction and training recipe. TileLang published a tutorial on tensor core kernels and autotuning. All 3 updates reduce friction between research and deployment. Sakana added a cyber endpoint to the Fugu orchestrator. Reactor released code plus a browser demo for OpenDreamer. TileLang shows a Python-level workflow to compile and autotune CUDA kernels. Start with Sakana's Fugu Cyber. Model ID, Fugu Cyber v1.0. Sakana reports 86.9% on CyberGym and 72.1% on CTI REALM. They present CyberGym and CTI REALM as complementary evaluations. MarkTech Post cites comparison figures such as 83.1% for Claude Mythos Preview and 85.6% for GPT 5.5 Cyber. Fugu is an orchestrator language model. It builds an agentic scaffold from a query and delegates subtasks to specialist models. Trinity defines thinker, worker, and verifier roles. The conductor learns coordination via reinforcement learning. Sakana emphasizes the verifier for security validation. Routing details are proprietary, and access requires a reviewed application. Pricing and access details matter for adoption. Now OpenDreamer. 2 repositories, a training pipeline, and a local rollout harness. Dynamics model, 1.6 billion parameters. Config, 30 block causal layers. D model, 1920, 30 attention heads, 3 kV heads. Every 4th layer is time attention. Each time step has 32 learned register tokens. Tokenizer emits 512 latent tokens per frame at bottleneck width 16. Tokenizer is a masked autoencoder, not a VAE. OpenDreamer publishes the full training recipe. Training: 200 0 steps with muon and a WSD schedule. Peak learning rate 3E-4, EMA decay 0.999. Shortcut samples start at step 100 at a 0.25 batch fraction. Muon replaced LaProp to improve stability. Activations dominated memory, so data parallelism plus activation checkpointing was used. TileLang is a Python DSL that compiles high-performance GPU kernels via TVM. The tutorial covers tiled tensor core GEMM and fused epilogues. It implements register-resident row-wise softmax and a fused FlashAttention forward kernel. Generated CUDA inspection and device debugging are shown. Auto-tuning searches tile sizes, pipeline depth, and thread counts. What this means for engineers. Fugu Cyber, managed orchestration for security workflows with gated access and token pricing. OpenDreamer, a reproducible Dreamer 4 recipe, but needs sizable GPU resources. TileLang, a path to convert algorithms into tuned CUDA kernels with per-device auto-tuning costs. 3 complementary advances across the stack. Fugu, orchestration for security reasoning. OpenDreamer, full Dreamer 4 training recipe. TileLang, kernel generation and auto-tuning. Watch adoption. Fugu integration. OpenDreamer reproducibility. TileLang tuning results. Find the sources in the description. Sakana Fugu Cyber. marktechpost.com/2026/7/25/Sakana. OpenDreamer. marktechpost.com/2026/7/25/OpenDreamer. TileLang tutorial. marktechpost.com/2026/7/25/TileLang tutorial.